Hello everyone, welcome to the lecture series on 8051 microcontroller. In the previous lectures, we had looked in terms of time delay calculations. So we had gone through why actually the time delay is required. So what are the its uses when in order to generate the time delay. So we had looked in terms of examples like how to calculate the delay in terms of machine cycles, like we had gone through the different data sheets of uh, what is the machine cycle required for in order to complete an instructions. Okay, some instructions takes only one machine cycle and some instructions take two machine cycle, and some of the instructions take somewhere around four machine cycles. So based on that, how to calculate the delay, that we had looked into. So we had looked in terms of some of the programs. So for that particular program, so what is the delay which is being generated for that particular program, that we had looked into. And at the end of the session, we had looked in terms of how to write a code in order to generate a delay of 1 millisecond. Okay, so in today's lecture we shall look into some of the simple assembly language programs with loops. Okay, so here if you look at the question, what they have asked is write a program to count number of ones and zeros in an 8-bit number located at a given address location and store the count value in the given address location. So here they have given the source address to be 30 hexa and the number of ones address should be stored in 32 hexa and the number of zeros should be stored into 33 hexa. Now if you look at this, let us try to solve how to find out. Let us see how to write down the program for this. Before moving on to how to write the particular program, we need to understand so what is the logic behind in terms of how to calculate this thing. So actually the what we are having is we are having a data which is present at 30 hexa location. Okay, so I need to get this 30 hexa location data. So this is going to be an 8-bit number. Okay, so this I should bring that to where I need to bring that to accumulator. So basically from this accumulator, now if you let me take an 8-bit number over here. So let me draw 8-bit number. Okay, let 0 1 2 3 4 5 6 7 and at last it is going to be 8. Okay, so this is the 8-bit number what actually we'll be having. Okay, now let us consider that in this particular 8-bit number I'm having some data, something to be like this: 1011 0 1 1 1. If you take in terms of 4-bit, the hexadecimal number of it is going to be B7. Okay, so this is going to be B and this is going to be 7, so it is going to be B7 hexa. Okay, now the total number of ones are here are 3 plus 3, so it is going to be 6, and the total number of zeros are 2. So how to calculate this particular thing? So that is what, first I'm going to take the data which is this particular data is present where it is present in this particular 30 hexa. From 30 hexa I'll load that thing to accumulator. From accumulator I'll be performing some operations. So that operations will be, I'll need to check each and every bit whether this particular bit is high or not. So for this particular thing, what I'll be doing, I'll be using this carry flag. Okay, so this carry flag I'm going to check. So the data, the bits which we are going to check, they are present in this particular register, that is in accumulator. So I need to get these data into carry flag and then I need to check whether it is 0 or 1. Based on that I am going to increment some of the registers. So this data should come to this carry flag. Okay, from carry flag again it has to roll back to this. Okay, so this is somewhat familiar, that is our RLC operations, that is rotate left with carry. Okay, so what we are doing, I'm going to move this particular bit to carry flag, and then I'm going to check whether carry flag is high or not. Based on that, I'm going to increment the value. So let us not directly jump into how to write down a program for both zeros and ones. First, let us look into how to write the program in terms of how to write down the program to count number of ones, and after that let us look into how to write down the program to count number of zeros. After that, let us look into both the number ones and then zeros. So actually what we are doing, get the data to accumulator, from accumulator we perform rotate left with carry. Okay, from that what we are going to do is I need to check my carry flag. Okay, so if it is 1, then what, you increment, or if it is 0, then what I should, if it is yes, then increment, if it is no, then I should not perform anything, and then I should come out of that. Okay, now this is only one for what, this operation is done only for one bit, but the total number of bits are 8, so I need to repeat this. So okay, so after incrementing, it should again come back to this rotate left with carry, and then again it should check this carry flag, and if it is true, then it should increment, otherwise it should come back. So how many number of times it should be repeated, this should be repeated, this loop, it should be repeated 8 number of times, because the number of bits what we are having over here, it is an 8-bit number. Okay, so based on this flow graph, let us try to solve how to write down the program for finding out number of ones. Okay, so let us take something like this. Let us start our program with 00 hexa. Okay, and let me get the data from, since it is located at 30 hexa, I'll be bringing that to my accumulator. Okay, we have bought that particular thing to our accumulator. Now what I should do, from accumulator it has come, I need to perform this rotate left with carry, which that is going to be accumulator. So RLC we have done, and then what I should do is that I should check for whether carry is high or not. So let me check, let me go in terms of a jump. If no carry, where it has to go, it has to go to this skip. If carry is not present, you just go to skip. Otherwise, if carry is not there, then what I should do, I should increment what I, let me take that to be register R1. Okay, so here we had given that it is going to be skip, so where it is, it should come directly over here. Here what, here actually we have incremented that thing. What should happen is I need to get back to loop, so this loop I need to do. So this loop, how much number of times it is going to be repeated, it is going to be repeated 8 number of times. So for that, let me use my instruction djnz. So for that particular thing, let me take my R3 as my value. So what is the data? So it is going to be 08, because the bits are total 8. So what I'll do, djnz R3 comma, where it should go, again it should go to RLC. So RLC, I'll give that label name as again. So here is my RLC, so I'll give this as again. Okay, it is going to come back over here, and then at last, what, once it gets completed, it has to store, it has to be stored where, it has to be stored in 32 hexa. So I'll take from where it is, the it is present in R1, I'll bring back that to accumulator. From accumulator, I'll move that particular data to 32 hexa location. Okay, so at last end. So let us check whether the program what we have written it is correct or wrong in key microvision. Okay, so let us see. So let me build it. So zero errors. So this is P7 hexa. It is present where it is present in 30 hexa. So let me load that particular thing with the B7 hexa. Okay, now let me check. Let us go in terms of step by step. So R3 has been loaded. RLC has been loaded. Okay. Before that, before this jump if no carry. Okay. Oh, yes. So here no carry is present. Now if you look at this, carry was present at this thing. So left has happened. So one has come over here. The carry has been generated. So here it is going to check jump if no carry. So no, carry is present. So jump won't be there. Directly it is going to come to increment R1. So R1 has been incremented. Decrement R3 and then go back to loop. So decremented and it went back to loop. Again you check for RLC. Now if you this particular 0 has come to this carry flag now. Now there is no carry being generated. So J and C. So I should not increment. So directly I should come where I should come here to this particular D, J and Z. So it has been skipped and then it has come over here and then increment did not happen. Directly it has been decremented. So after this, once if you look at this particular operation, okay, so here we have got the total number of ones to be 6 and the number of ones which are present in this 8-bit this thing it is 6. Okay, now if you want to be in terms of what should be done if we want to count number of zeros. Okay, before that just what extra change what we can do is here we were checking for jump if no carry. Let us skip that part. If one is present then it has to skip. Okay, that is why here we have given jump if carry skip. Okay, if you get one then you skip, if you get 0 you increment. So now if you look at this, now let me load back again B7 cell. Now if you look at this R3, A has been loaded, rotate left with carry, so carry is 1. Since carry is 1, it is going to come directly over here and then again it is going to go back. Now 0 is being there, so carry is not present, so it is going to increment what? It is going to increment R1. So at the end of the result your R1 will have 0 to hexa. Okay, that means what? It is having this 0 to value. Okay, so this is how we have done in as a single program. We had looked in terms of what? We had looked in terms of how to calculate how to count number of ones, and then we had looked in terms of how to write down a program for 1 into zeros. So if you are counting number of ones, then J and C we will be using, because in order to skip the 0 count. Okay, if we are using if you are going to go for zeros count, then I'll be changing this to jump if carry, so because number of ones need to be skipped. Okay, so that was for in terms of ones and zeros. But if we need to perform both the operations in a single program, so what actually we can do is that, so the count is going to be same, that is going to be 08, and then the data which is coming over here again it is going to be same. Now if I perform this RLC, okay, so here let me go back to this. Again what I'll be doing, I'll be checking my carry flag. So jump if carry, so let me take a label here. Okay, if carry is present, it has to go there. Let me take in terms of uh, I'll take R0 for ones, and then let me take R1 for zeros. Okay, so jump if carry, so it is going to come where? It is going to come here. Okay, so in here what is going to happen? So that here, in the sense, what it is going to be, that what a 1 is present. Whenever 1 is present, my R0 should be incremented, so I'll write increment R0. Okay, if this condition is not true, then that means that the carry flag is 0. That means I need to increment what? I need to increment the number of zeros counter, that is going to be increment R1. Okay, so increment R1. So here what happens is that, again, what it has to be in a loop. Okay, so what I'll do is that I'll use my djnz R3, comma, where it has to go, it has to go to again, so let me write it as again. Okay, now the problem is that, now if you, here I need to what, here it is going to check what, here it is going to check whether the carry bit is high or not. If it is not high, it is going to increment this R1. Okay, if you don't include again a jump, because once it gets incremented, it should not increment this R0. It should come, see, this particular thing, once it gets incremented, it should come directly where? It should come directly over here. This operation should be skipped when we are when we have executed this. Okay, here there is no problem. Jump if carry, it is going to come directly over here. After this R1 is not going to increment anywhere in the below lines, so it is going to be directly djnz. But here, if you look at this, here we are incrementing this R1, and then if I don't include any jump, and if I come over here, even my R0 is going to be incremented. So this incrementation of R0 need to be skipped. That is why what actually we are doing is that we are going to include a skip over here. Okay, so what I should do is that it should come directly where? To decrement. So for that, let me use this S jump, that is my short jump. Where it has to come? It has to come directly over here. Let me use something like label. Let me name that as label 1. So that label 1 is going to be present where? It has to come over here for this. Okay, so short jump label 1, it is going to come here, and then my R0 is going to have number of ones, and then my R1 is going to have number of zeros. Those need to be what? Those need to be stored in 32 hexa and 31 hexa. One way of writing this particular instruction is, as we know that our by reset register bank 0 is going to be selected. As we have used only R0 and then R1, my address location of R0 is going to be 00 hexa, and then R1 is going to be 01 hexa. So I can use my direct memory mapping. Okay, direct addressing mode 32 hexa, comma, what it is going to be 00 hexa. And then one more thing is like 33 hexa, comma, 01 hexa. So this memory mapping we can do, or else what I should do is that I need to get that particular data which is present in R0 to accumulator. So R0, from R0 I will move that particular thing to where? To my 32 hexa, and again let me bring that contents of R1 to my accumulator. Again I need to send that particular data to my address location 33 hexa. So this is how it is going to be done, right? So actually what we have done with RLC, and then if carry is present, it should increment R0. If carry is not present, if this is not satisfied, it is going to increment R1. After this, we should not directly, since it is going to be if I don't include this jump, it is going to include again this increment R0, and then simply R0 is going to be incremented. That is why I need to increment this short jump, and then it has to come over here, and then it has to perform the operation. Okay, so let us see that whether our program is working fine or not. So let me open this skill microvision. Okay, so let me okay, sorry for that. Let me load these values. Now if you perform this operation, let me so zero errors. So let me load this thing in terms of what over here. So let me load my values with B7. Okay, now if I perform this operation, you can see over here after the execution, the number of ones are 6 and the number of zeros are 2, same value what we are having over here. Okay, so this is how we are going to execute this particular operation, how actually we are going to count the number of ones and zeros in a single particular program. So in the next lecture, so let us wind off this thing. So in the next lecture, let us see some more examples, like how to write down the